All right, sweet. All right, so here we go. pH and pOH. We'll start by a moment of review here. So what we already know. What we know is, if we know the hydrogen ion concentration, right? Let's say it's 10 to the minus 6, right? Molar. Then what's the pH? Just 6, yeah. So the pH is just the exponent, right? So this is what we know. This is easy. Now, what I'm going to tell you today is there's a relationship between the concentration of hydrogen ions and the concentration of hydroxide ions, or the molarity of those. And the relationship looks like this. If you multiply them together, concentration of one times the other, you always get this number. It should be a bracket. You always get a number. It's always the same number. And that number is 10 to the minus 14 molar. Right? So this is kind of strange because what this tells us is that water is always going to have some hydrogen ions and some hydroxide ions. So the concentration of the two multiplied together is always constant. So there must always be some of each. It can never be 0 for either one of them. Okay? So looking up here, right? We have hydrogen concentrations 10 to the minus 6. So then what's hydroxide concentration in that situation? So let me just do that for you. 10 to the minus 6 times some number that we don't know equals 10 to the minus 14. So what's this got to be? And if you solve this, what you're going to get is 10 to the minus 14 divided by 10 to the minus 6. Oops, 6.
Please pardon the interruption. I need to see Miss Kasmer, Miss Lodds, and Miss Van Zura in the main office for just a moment, please.
All right, so if you're good at math, you can do this in your head. If not, you can plug it into a calculator. When we divide exponents, we're really just subtracting the bottom from the top, right? And since they're both negatives, when we subtract them, it's kind of like subtracting the regular way. So this just becomes an 8. The answer is 10 to the minus 8. So what this tells you is, if hydrogen concentration is 10 to the minus 6, hydroxide ion concentration is 10 to the minus 8. 6 and 8 adds up to 14. Those numbers are always going to add up to 14. Make sense? So that's what, basically, if I erase this, that's what this tells you. If this is 10 to the minus 5, this can be 10 to the minus, what would that be, 7? 9, sorry, 9. If this is 10 to the minus 4, this would be 10 to the minus 10. The two numbers are always going to add up to 14 in two exponents. All right? And then, coincidentally, because of that, that means that pH, which we know about, and pOH, which you can guess what that is, it's a measure of hydroxide concentration, are always going to add up to 14. In other words, the exponents are always going to add up to negative 14. All right, how many people are with me so far? All right, good. All right, so let's do, where you go? Stop doing it. Right over a little bit, too. Let's do just one problem, and we'll keep this short. So, if hydrogen ion concentration, that's supposed to be an H, equals 10 to the minus 3 molar, what is the concentration of hydroxide? What is the pH? And what is the pOH? Yeah, so what's going to be 11?
The pOH.
Yeah, the pOH is going to be 11.
And the pH is 3.
pH is 3. Oops, that's not a 3. And then finally, what's the hydroxide ion concentration? Well, 10 to the minus 11. Right? Molar. So this is 10 to the minus 3. This has to be 10 to the minus 11. The two exponents have to add up to 14. Okay. All right.
How do you get 11?
11 plus 3.
11 to
So, which one are you talking about? This one or this one?
That one.
The top one?
Yeah.
Okay. So, pH plus pOH equals 14. So we know what the pH is just by looking at this, right? If you're not sure by looking at it that it has 3, you can always plug in the old equation, pH equals negative log of H plus concentration. So negative log of that number is just going to be 3, right? So this is 3, this is 14. Where does it have to be? It has to be 11. It's 14 minus 3. You good with that? That's up to 14. All right there?
Can just throw your stuff around, it's fine.
He's pretty unhappy about this. All right, and so the same thing for the concentrations. Negative 3, negative 11 adds up to negative 14. All right, so the exponents will add up. Should I do another one of these?
No.
Okay. Yes, they got like mixed yoses in those. All right. So, all right, this one will actually like write out the math a little bit here. All right, so I'm going to give you something that's not going to be a whole number this time, so you'll actually have to use a calculator. Let's say hydrogen concentration is 2.5 times 10 to the minus 8. Okay? All right, and the questions are, what's pH? What's pOH? And what is hydroxide concentration? Okay, so to find pH, we actually need to use a calculator this time. It's going to be pH equals negative log. What's up, honey? I'm sorry. I'm not very exciting. Yeah. Get that out of there. All right, so we actually got to plug this one in. Obviously, the number should be somewhere close to 8 plus or minus 1 there. Somewhere in there. 7.6. Okay, so we got pH, 7.6. Okay, now to find pOH, this is really simple. It's going to be 14 minus 7.6. 6.4. Okay, and finally, find hydrogen ion concentration. Oops, hydroxide ion concentration. It's going to be 10 to the power of negative 6.4. And you'll have to plug that into a calculator. Obviously, it's somewhere between 10 to the minus 6 and 10 to the minus 7. But it'll be, you know, some sort of actual number. There we go. So that's this one. Good? Okay. A couple things outside of all the math from this, right? What does this tell us? Well, in neutral water where the pH is 7, what's the pOH? Also 7. So neutral water has 10 to the minus 7 concentration of hydrogen and hydroxide. When we add an acid to water, hydrogen goes up, that eats up some of the hydroxide, so that's why that number goes down. Vice versa, if we add a base, the hydroxides eat up some of the hydrogen, so hydroxide goes up, hydrogen goes down. So that's sort of what this tells us. All right, you good? You're good. All right, you can turn that off. I'm done. You can be happy, or else your daddy's done talking now. What's up?